Ever wondered how to find the longest substring with repeating character when you can replace up to k characters? So today we'll break down the optimal way to solve in just O of n time. So without wasting much time, let's get into the problem statement. Today we're going to see about longest repeating character replacement problem, guys. And what is the problem I ask you to do is you'll be given a string s and integer k, and where we can replace up to k element to make a substring look exactly same. For example, if you take this particular substring, you can change b to a and here also b to a, and all the characters look same. And like that, you need to find the longest repeating substring up to k replacement. That's what a given question is. Now let's talk about the optimal solution very quickly, and we are not going to be involved into this much because we already know we are going to implement two-pointer techniques and sliding window concept. So just a quick hint like how to do a brute force solution. So in brute force solution, as we discussed in a previous problem, will generate all possible substrings and we'll check if the given if the given window is valid or not. How to check that? It's very simple, guys. What you can do is please note this formula very carefully. Like changes needed is equal to window size minus the maximum frequency. This is the formula which will tell you that your particular string is valid, substring is valid or not. What this changes needed? So the changes is needed nothing but how much character you need to change so that the entire string become same. Let's take this small example like okay fine, b a b a. Okay, let's take this example. Now what is the window size? The window size is going to be 6. Okay, the window size is going to be 6. And what is the maximum frequency here? Maximum frequency is character a, which has 4. Now if you do this, you have 2, which indicate you can change the 2 character so that entire string become same. If you see this b, if we change b to a, this entire string becomes same, right? That's what this change is needed telling. You need to change 2 particular characters so that entire substring looks similar. So remember this formula while writing the brute force. Check this, like changes needed is equal to windows minus maximum frequency, the current window minus max frequency. If this is less than or equal to k, then this is a particular valid substring, right? We cannot have greater than k because the question asks you to do at most you can change the k characters. That's why if this condition succeed, we can tell that this particular string is valid. For example, if I take okay fine, let me take this c. Now our string substring become invalid if we substitute formula again. Now the window size is 7, and what is the maximum frequency? Maximum frequency is again 4. If you do, you need change at most 3 character to make this valid, but our k, let's assume k is 2. So does it possible even if you change this to a and this to a, still this is invalid because c is outstanding characters. That's why you do this condition less than or equal to k. Just remember this because we are going to use this entire solution as well. The changes needed is going to be max windows minus max frequency, and if it's less than or equal to k, we can surely tell that the substring is valid substring. Now let's talk about the optimal solution or brute force one. As always, sliding without 2 pointers, we are going to have 2 different pointers, which is left and right. So we just declare left and right at the starting position. And let's talk about the actions before starting in the dry run table. The possible actions are expand, and another possible action is shrink. In always 2 pointers, we have only two actions. One is expand option, which will just expand the window, and we have shrink action, which just shrink down the window. So for expand, we always need to move the right pointer, guys. Remember, in whatever problem you're facing, for expand, you always move the right pointer. And for string, you always move the left pointer. So just keep this in mind. And this changes. So the formula is going to be size or window minus max frequency. And this determines the action. If this is less than or equal to k, we'll just increase the window. If this is greater than k, we just shrink the window, guys. Let's see 2 important cases. And now let's move to the dry run table. As initial first step, the current window is going to be B and the maximum frequency is 1. Now to keep track of the maximum frequency, we'll use hash map. Let's do an hash map like this. Let's put B into the hash map and the current count is 1. Now let's calculate the changes. Changes need is going to be 1, which is the window size minus the max frequency. It's going to be 0 and this is less than or equal to k, right? 0 is less than or equal to k. Now our action is going to be expand option. So now let's expand this window BA. Now the second operation is BA. And what is the maximum frequency? So let's add A to the hash map. Now this again the max frequency is 1. Now if you do this formula, like the window size is 2 minus 1, which is going to be 1, which is less than or equal to k. Again the operation is going to be expand operation, guys. Now just move this pointer next step. At the third position BAA, now the max frequency is 2, right? Now A repeated 2 times, so the max frequency is 2. Now if you apply the formula, the window size is 3 minus 2, which is again 1. Still this window is valid because you can replace B to A, which will make you AAA as a current substring. So just move this pointer. Now at the fourth iteration, our string is going to be BAAB. Again the same max frequency is 2, there is no changes, so we just update the counter of B and the formula is going to be changes is going to be 4 minus 2, which is less than or equal to 2. So right now we can change this B to A. Right now the max answer is going to be AAA, guys. So we just move the expand operation. At the fifth iteration, our substring is going to be BAA. Now our max frequency changes because A repeated 3 times, right? And we'll have 3 max frequency and the window size is going to be 5 minus 3, which is 2, right? Now tell me whether we can expand or not. Yeah, we can expand because it is less than or equal to k. Just expand the window right now. If we expand it, it's going to be like this. Now if you see the next iteration, the substring is going to be, this is our current substring. Now if we calculate the maximum window, I mean maximum character is going to be 4 because A repeated 4 times, right? Now if you substitute this formula, 6 minus 4, which is 2 again, and tell me whether we can expand or not. Yeah, we can expand because it's less than or equal to k. Now so just expand the window. Now at the next iteration, the substring will look like this. And again, as usual, there is no change in the max frequency, so it's going to be 4. And if you look at the window size, it's 7 and the max changes is 4. And if you do this, you will get 3. Now tell me whether it's possible to tell this particular string as a valid one. No, because it's greater than k, so we allowed to change at max 2 character, right? But right now we need 3 character to be changed, so we don't have that operation, right? So now what operation we need to do is shrink operation, guys. We need to do shrink operation. Shrink is very simple, that you just move this pointer to the next position and find the next maximum frequency character. If you move this, what's the maximum frequency? Let's do this right now. Now we have to decrement B to, sorry, right now the B is 3, right? After changing it, now we just move the left pointer. Now the B will become 2, and tell me this particular window is valid or not. Yeah, it's valid because the maximum frequency is 4 and the window size is 6. This is the window size. Now this is valid or not? Yeah, it's valid. At the 8th iteration, we'll be having A, B, A, B. This is the, at the 8th iteration, our string will look like, and the max character is going to be 4 and 6 minus 4, which will give you the 3. And now we have to do expand operation. Sorry, 6 minus 4 is going to be 2. Now we'll do the expand operation. Now just expand the window. Yeah, we just expanded it. Now right now you need to increment the B to 3, right? B to 3 at the next iteration. Now tell me, guys, whether this is valid or not. This particular subsequence is valid or not. Sorry, substring is valid or not. No, because again the max frequency is 4, and if you see window size is 7. 7 minus max frequency gives you 3. You need 3 characters need to be changed. But again, you cannot do that, right? So what do you have to do? We have to do string the window. Just string the window like this. If you do that, right now we need to decrease the a to 3, right? Because we shrink the window, so a must be 3 right now. Now just apply the formula. Now the current window is going to be 6 minus the max frequency. What is the max frequency? Max frequency is 3 right now. 6 minus 3, which will give again 3, which is again, it's not valid. So we need to again shrink the window. Just shrink the window again. We just shrink the window and we just update the counter, which is 2. And now just tell me this particular substring is valid or not. We have length of 5, right? 5 minus the max frequency. What is the max frequency right now? 3. 5 minus 3, which is going to be 2. Again, it's valid. So we got some valid subsequence right now, substring right now. Just put it in the next iteration, which is BAABB. BAABB, guys. Now the max frequency is going to be 3 and 5 minus 3 is going to be 2. Now we need to expand the operation. And I think let's stop this till here. I hope you guys understand what we have to do. So whenever we just have some invalid, whenever our substring become invalid, we just move this pointer one step. We just move the pointer and we'll just check whether our window is valid or not. If it's valid, we just keep on going it. If not valid, we just move the L pointer until unless it become valid. And in the meantime, we'll also update this maximum frequency because this plays a major role, right? So now let's talk about, now let's see the pseudocode for this. I think when I write pseudocode, you guys will understand much better. Now let's declare the left and right pointer and max frequency. Left is going to be 0 and right is also going to be 0, and max frequency is also going to be initially 0. And if you remember, we have hash map, right? Hash map. Or we can declare like this also, hash map of 0 into 26, because we have 26 characters. And now we'll start our while loop, or you can use for loop also. Now while is going to be while r is less than n, where n is going to be the size of string. As initially we'll just update the map, right? We always used to update this current map. So right now we do the same operation. Hash of s of r minus a, it's going to be plus plus. Now what you have to do is we need to update the max frequency. So max frequency is going to be max frequency itself and the current character. Current character is going to be hash of s of r minus the a. That's it, right, guys? Now what you have to do is we need to check the current substring window is valid or not. For that we can write simple while loop, while the window size. If you remember the formula, window size, for window size, if you remember, right minus left plus 1. Previous problem, go back to the previous problem, just understand why we use this particular formula. This will give the window size. Window size minus max frequency greater than or equal to k. This is like invalid condition. So what you have to do at the invalid condition is we need to move the pointer right. We need to move left pointer, or we need to shrink the window. We can simply do that like hash of s of left minus a, which is going to be decrement value, decrement by 1, and you need to move the left to the next position, left plus plus. And if you remember, guys, like whenever we just move, we have to recompute the maximum frequency, right? We have to recompute the maximum frequency. So we just write the code for this also, and we declare the maxi. This current maxi is going to be indicate the current maximum after shrinking the window. Now let's write the loop for I is going to be 0 till 26, and we just simply update maxi is going to be max of maxi itself, comma hash of I. Very simple. Right now we just compute the current maximum and just update it to the max frequency. Like if maxi is greater than max frequency, just simply update max frequency is going to be maxi. Very simple, guys. And right now this while loop, we have to close this while loop, right? We have to close this while loop. Now what you have to do is we need to compute the window size, the maximum window size. And I think I forgot to declare max length, guys. Max length is going to be initially 0. Now once the while loop finish, we need to check whether the current window is valid or not. If it's valid, we need to update the maximum window size, I mean the result. So for that, what we can write, if condition, if r minus l plus 1, which is the window, minus max frequency is less than or equal to k, which indicate the valid substring, right? Now let's compute the max length. So max length is going to be max of max length itself, if not the current window, r minus l plus 1. That's it, guys. Very simple. And don't forget to increment r, and then finally return the max length. This is a like very simple code. And now let's discuss the time complexity for this. If we talk about time, this will take O of n time, and this shrinking part will take again O of n time. If you remember in the previous problem, we talked about why this take O of n time at the worst case. So the overall time complexity is going to be big O of n plus big O of n. And if you remember this for loop, this particular for loop will take big O of 26 time, because whenever we just update the window or whenever we just shrink the window, we are just updating the max frequency. We're just finding it and I'm updating it. So this will again take big O of 26, guys. And if we talk about the space obviously we are not using any kind of extra spaces. Obviously it's going to be taking big O of 26, because we're using the hash map of size 26 to keep track of the frequency count of the characters, again, which is almost going to equal to big O of constant space. And this overall time complexity is going to be big O of 2n plus 26. And if we talk about the optimization, we can definitely do optimization here. Like what we can optimize is this max frequency. So do we really need to update max frequency? No, we don't need to do this. I will explain it why. Now let's take this example and explain why does recomputing max doesn't help the solution at all. Okay. Now the maximum length is already 5. So 5 minus the max frequency is going to be 2, which is the valid window. So what is the next possible valid window is 6, right? Next possible valid window is 6. And next possible is 7, next possible is 8. Our goal is to maximize the window length, right? Does 6 minus 3 contribute? Like does 3 contribute to this valid window? No, obviously no. 3 is not at all contributing to this particular case, because it violates the given condition. 3 doesn't contribute to it. Like which can be contribute to this value, which is the maximum value. So you just need to maximize the window. I mean maximize the max frequency, not minimize it. Okay, now let's assume that maximum frequency is 4. Now this window becomes valid, right? So just keep in mind, to have a better solution, we need to maximize the maximum frequency. We cannot minimize it. Let's say we minimize it and we're just shrinking the window, and let's say we have some more character and the max frequency become 2. Does 2 making our solution better? No. Again, this getting failed. So when our case is getting passed is when we have the maximum frequency. So let's say maximum frequency right now 4, which is contributing to our solution. So you always need to have the frequency to be maximized, not minimized. So we entirely remove this particular for loop. We can entirely remove this for loop, guys, because it's not going to be contribute to our solution. Time complexity becomes big O of 2n. And how to reduce this n also? How to reduce this? That's very interesting again. If you look at this particular example, I mean this particular space, the window size is 7, the max frequency is 4, like 7 minus 4, which is resulting in 3. You need 3 changes to make this particular substring valid, but we can at max we can make 2. So right now our window become invalid. So what the while loop does is just keep on shrinking the window size until unless it become valid window. So do we really need to do that? Means no, you don't need to really do that because we already have this much maximum frequency. So our goal is to make the better solution, right? So there's no point in making it down, shrinking down. So what you can do is just move the one pointer. I mean, just shrink the window only one size instead of moving two or three window. Just move it only one single space, and now your substring will look like this. Now just check the condition whether it's valid or not. If it's valid, if it met this condition, just increase the window size. Until unless you don't need to do like multiple jumps, you can just shrink only one single space, which will obviously result in a better solution. So you don't need to make it shrink it down very much. It's not going to make you to the better solution. So always just move only one step ahead. If you see instead of while loop, just change it to the if condition. That's it, guys. Right now this O of n is also cancelled out. Now overall time complexity is going to be big O of n. I hope you guys understand this. Again, I'm telling it's very hard to understand this particular intuition. So now let's code this up. Now let's declare the left and right pointer as well as the maximum frequency, max length. Left and right is going to be 0, and the again max frequency and max length is also going to be 0. And if you remember carefully, we need to have the character map, or we can check hash map. The char map is going to be default dict, and we'll start the while loop. While right is less than or equal to given length. And if you remember carefully, we need to update the character map at the beginning itself, right? Char map of s of r plus equal to 1. And if you working on CPP language, you need to s of r minus a, which will result you in the particular index position. For that, you need to have a declaration like this. Char map is going to be 0 into size of 26. Like that, you need to have the declaration. And if you do this particular thing, you will get the index position. You can directly do this thing. For Python, I'm using default dict, so I don't have to do this thing at all. And then next step, you need to add the max frequency, update the max frequency. Max frequency is going to be max of max frequency itself, comma, the current frequency, the current character frequency, the char map of s of r. And I think I did small typo. Let's add q here. Yeah. And then if you remember carefully, we don't need to string down the entire string at all. We can string only one string. We can have this particular window size and check whether this window is valid or not. If it's valid, just update the max length. If not, just move only one step ahead and keep it like this. That's our main goal. If r minus L plus 1 and minus the max frequency is greater than k. If it's greater than k, just move left pointer only one step. So char map of s of r, s of left is going to be decrement to the 1 and move left plus 1. That's it, guys. You don't need to string the entire window, just move only particular max frequency. Now if the window is valid, now we need to update the max length, right? So max length is going to be max of max length itself, if not r minus L plus 1. That's it. Now we update the max frequency, max length. Now we can directly return the max length itself, return max length. Now let's submit this code and see. Oh, I just misspelled. I just did a small typo. Let's fix this. And now let's run this. Oh, I'm idiot. I forgot to increment the pointers, right? Always forgot to increment the pointer whenever you're working with while loop. Okay, guys, now let's run this. Yeah, it passed the test cases. Now let's submit this and see whether it's passing all the cases or not. Yeah, it passed all the test cases, guys. I hope you understand this particular problem. And we'll meet again in next video. Until then, bye. I think next video will be last of the sliding window pattern. So practice well and come back and watch the next video. Bye.